Section 115, Connecting Limits at Infinity and Horizontal Asymptotes. So this section is about limits that are approaching infinity, positive or negative. And what is the result equal if you take a limit to infinity? That's basically saying as a graph goes to the right, what's happening as you go on forever to the right? Is it going up? Is it going down? Is it approaching an asymptote? Or if it's saying as limit approaches negative infinity, it says as you go to the left, what's happening? Is the graph coming down? Is it going up? Is it going to negative infinity with positive infinity? What is it doing? So it's basically about end behavior. This limit right here talks about the end behavior of a graph. Now, if when you do this limit, you get one of these this notation, what you do is you divide both the numerator and the denominator by the highest degree in the denominator. That is going to be a procedure that you are going to do in order to solve limits. So let me show you a little example. If I have the limit as x approaches positive infinity of, say, x squared plus x over x squared, or 3x squared minus 2. Well, what's the highest power in the denominator? It's an x squared. So what we do is we go and divide each piece by x squared. That's what it's saying. And when you do that, something's going to happen. Something's going to happen. I guess I'll just show you real quick. It's going to become equal to the limit as x approaches infinity of 1 plus 1 over x over 3 minus 2 over x squared. So once I do this, I get a new, all I did is I simplified. Because basically I did is I multiplied top and bottom by 1 over x squared, which you can do that. It's just kind of creepy. So all I'm doing is changing the way it looks. And so this new look is better. Anybody like, how does that help me? It doesn't help at all. Well, it does. And that's why this little strategy helps us do limits to infinity or negative infinity. And here's where it comes next, this next statement. If n is positive and c is a constant, then the limit as x approaches infinity, positive or negative, of a constant over x to any power is 0. Now what does that mean? What? That means if I have the constant 3 over, say, x to the third, if I plug an infinity into that, don't I get 3 over infinity cubed? So if you really think about that, that's 3 over like 99999999999 forever. So isn't that, if you really think about that, isn't that really just approaching about 0? Isn't that getting so small? So 3 divided by an infinitely big number is approaching 0. And that's what limits are. It's about what you're approaching. So we're actually approaching 0 if you have a constant divided by x to any power. And when you plug in infinity, you approach 0. With that said, won't you for this problem now plug infinity for all x's? So if I go and put infinity into this x and infinity into this x, let's think what happens. Won't this become 1 plus 0? Because what I just said is a number over infinity, isn't that equal to 0? So isn't it going to be a 0? And isn't 2 over infinity squared, isn't that also 0? So really, isn't this really just saying 1 plus 0 over 3 minus 0, which that is equal to 1 over 3. So what that means is 1/3 is what this graph is approaching as x approaches infinity. So if you were to think about this, if this was a graph, what we know is, and say this is 1 right here, there's a horizontal asymptote of 1/3. And what we know is this graph, as you go to infinity, is either coming up across like that, or it could be coming from the bottom like this, or in different things, it could have gone woo, 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 but maybe come back up along that 1/3. Again, this is 1/3 here, is where it's at. So that 1/3 asymptote is telling us what the graph is doing as you go to infinity. And if you plug in negative infinity, well, that will tell us what it's doing the other way. So what is it going to do as you go this way? Well, if you plug in negative infinity, won't that still be 0? You put a negative infinity here, won't that still be 0? So it doesn't matter, it's still 1/3. So both ways, it would actually be approaching this asymptote in both directions. So to recap that, what we're going to do is we're taking limits to infinity. We divide, according to what this is say, by the highest degree in the denominator. Once you do that, you get a nice little piece that most likely, when you plug in infinity, you will get things that become zeros, that disappear, and you will be able to see your answer.